Okay, so there are kind of two ways that you can evaluate piecewise functions. We can evaluate them just by looking at them as a graph, and we can evaluate them just by looking at them as the function equation. Okay, now I'm going to start with the graph actually, because I think that's what we're a little bit more familiar with. So I'm going to start over here at this example. Okay, I have this graph. I don't know if you can read this super well, but this line here on the left, that is y equals 2x plus 3. And this line here at the right, that is y equals negative x plus 4. Okay, I want to evaluate these three values, f of negative 2, f of 1, f of 2. So when my x value is negative 2, what is my y? When my x is 1, what is my y? And when my x is 2, what is my y? Okay, so let's start with negative 2. If I go to negative 2 on my x-axis, my y value is negative 1. Okay, notice on that piecewise function, it is only defined on this left piece of the graph. Okay, at f of 1, here I kind of reach a little bit of a gap. Okay, which one of those points defines my y value at f of 1? And that's where you've got to look at what's included and what's not. This solid point, that's included. This open hole, that one is not. So when I'm looking at f of 1 and I want to know what the y value is, I'm going for that solid point here. So f of 1 is equal to 5. Okay, and then f of 2, here's my x value at 2. Again, this is defined now on the right piece of the function. Okay, and that would be, looks like y equals 2. Okay, not super horrible to look at it graphically, because you're just finding those x values and then piecing together where the y value exists. Okay, now if you're looking at piecewise functions algebraically, this is a little bit different of a notation. Okay, piecewise functions algebraically are written as a piecewise function is defined. So I think on your previous slide, it says piecewise functions are defined as two or more functions on a specific domain. Okay, here's the equations. Here are the specific domains. Okay, so f of x, this piecewise function, has the equation x squared plus 2 only when x is less than or equal to 1. And then it has the equation 2x squared plus 2 only when x is greater than 1. Okay, if I were to look back at this first example that we played with, let me use g of x actually. I would say that g of x would be 2x plus 3 only when x is less than or equal to 1. And it would be negative x plus 4 only when x is greater than 1. Okay, x is that, at x is 1, that's kind of the splitting point on this piecewise function. Okay, same thing over here. So that's where you get kind of the different looking graphs. They almost look like they're in sections. Sometimes connected, sometimes not. So now if I want to evaluate this, I have to pay close attention to my domains. So if I want to know what is f of negative 2, I want to know which domain does negative 2 fall into. So is negative 2 less than 1 or is negative 2 greater than 1? Well, negative 2 is less than 1, excuse me. So I'm going to plug it into the first equation. Negative 2 squared plus 2. I get 4 plus 2 is 6. So f of negative 2 is equal to 6. Okay, f of 1, where does that fall into? Well, I see a 1 and a 1. The only one that it's actually equal to is this first one, equal to 1. This equation is only true if x is greater than 1, okay, not equal to. So again, I'm going to plug that into the first equation. 1 squared plus 2, I get 1 plus 2, so I should write that out, is 3. So f of 1 is equal to 3. And this last one, f of 2, okay, that falls into this domain. 2 is greater than 1. So at that, now I can plug that into the second equation. 2 times 2 squared plus 2. 2 squared is 4 times 2 gives me 8. 8 plus 2 is 10. So f of 2 would be equal to 10. Okay, so when you're evaluating these piecewise functions, figure out which domain your x value is a part of, and then substitute it in for that equation. Questions on that? Let me know.